Okay, this video is to review all the different types of factoring that we have learned, and then we'll have a review activity and a quiz coming up. But I like this little handout, and again, I've been trying to stress throughout learning our different types of factoring that you should always check for a greatest common factor first, and that's what it's saying here in this big bubble on your handout. Okay, always check for a GCF. Think something might not have one, but it's always your first job to check for it's there. Now, I like that it shows the terms to help determine the type of factoring. If there are two terms, then we're going to be using difference of squares, most likely. If there are three terms, we're going to be doing our 1, 2, 3 factor tree, and there's two situations there. There could just be where we get to jump into our factor tree, or maybe it's a slider because there was a number we couldn't take away from in front of our x squared. Or if there are four terms, we are going to do our grouping, which was the last one that we just learned, where we make two groups and we take a GCF out of each group. All right, so let's practice with each of these methods. Let's start with difference of squares example here. So remember, we always have a certain method to do with difference of squares. So in our first example, we have x squared minus 64. I'm going to check for a GCF first, and I can notice that because x squared doesn't have a number in front of it and 64 doesn't have any x's, there's not a GCF for this problem. But when we're doing difference of squares, we always factor in the same method. We make two sets of parentheses. One set gets a plus sign and one gets a minus sign. Then we're undoing squares, and the way you undo a square is by square rooting. Okay, so we take the square root of our x squared, and that is x. So we put 1x first in each set of parentheses. And then our second term is 64. The square root of 64 is 8. So we put 8 second in each set of parentheses. So x squared minus 64, the multiplication problem that gave us that was x plus 8 times x minus 8. All right, and then our second example, we have 18m squared n minus 2n cubed. Well, I know that 18 and 2 are both not perfect squares, but we're in that section. But remember, it says check for greatest common factor first. So we need to take out a GCF first on this one. So what's the biggest number that goes into 18 and 2? Well, that would be 2. That divides in evenly to both of these. Now, do they have any variables in common? Okay, this one has 1n. This one has 3. So they both have n's, but we can take 1n out from each. So we have a GCF of 2n. So our first job is to just divide that away from each. So 18 divided by 2 is 9. We're going to keep the m squared, but we lose the n because that was part of the GCF. We're going to divide our second term. So negative 2 divided by 2 is, we have a negative 1. And 3 n's take away 1 n is 2 n's. So remember, anytime we divide by a GCF, we have to put that part in parentheses, and we put the GCF on the outside. But now if we look at what's left in the parentheses, we have a difference, a minus sign, in between two perfect squares. 9m squared and 1n squared are both perfect squares. So now we just keep bringing down that GCF. Now we're going to do what we did before. We're going to make two sets of parentheses. One will get a plus sign, one will get a minus sign. We're going to undo the perfect squares by square rooting them. The square root of 9m squared is 3m, so that goes in each set. The square root of 1n squared is 1n, so we put that in each set. So now this is fully factored. Okay, what multiplied to make 18m squared n minus 2n cubed? It is 2n times 3m plus n times 3m minus n. So that was our difference of squares. Okay, now we're on to our three terms sections. We have two different types of trinomials. Okay, in this first one, I'm on the left. This is when we do not have a number in front of our x squared to begin with. Okay, so remember, we want to do a 1, 2, 3 factor tree. We just can't do that factor tree if there's a number in front of x squared, but this one doesn't have one. So this is where we're doing a puzzle. When we factor it, we do want to make it into a FOIL problem, but we need two numbers that multiply to the last number, which is negative 42, and they add or subtract to the middle term. In this case, it's negative 1. So what are the only two numbers that will do that? Well, I know 42 is 7 and 6. So if I have a negative 7 and a positive 6, those two numbers multiply to negative 42, they also subtract to negative 1. And because I'm dealing with x's, I know that x times x makes x squared. So we just put one x in each set of parentheses. One gets the minus 7, the other gets the plus 6, and that is fully factored now. Okay, we also learned that we don't always have to slide if there's a number in front of our squared term. Sometimes it's it's just a GCF. So in our second example in this box, we have 2w squared plus 20w plus 50. Well, I can't do my factor tree with this 2 in front, but before I slide it, the better, faster, easier way would be if it came out as a GCF, and 2 does divide evenly into all three of these terms, so we're going to divide it out, and that will leave us with w squared plus 10w plus 25, and we divide 2 from everything, but we still have to put that GCF on the outside. But now we can do 1, 2, 3 factor tree. We're looking for two numbers that multiply to 25 and add to 10. Well, that should be pretty clear. That's going to be 5 times 5. Okay, so now we'll just rewrite it. We have 2, and then we're going to say this is w plus 5 times w plus 5. Now remember that if we ever have the same factor twice, like we have w plus 5 in each set, maybe a better way to write it would be like this, 2, and then we have w plus 5, and because there's 2 of them, I could say that part is squared. The squared means there are 2. Okay, our other trinomials we said slip and slide or slide divide bottoms up. This is when we have a number in front of our x squared that cannot be completely removed as a GCF. So looking at 30x squared minus 27x plus 6, I'm looking first for a GCF. Do 30, 27, and 6, do they share a common factor? And they do. We can divide 3 out of each of them. So it won't get rid of our leading coefficient still, but it will make it smaller, which makes it more manageable. So when we divide 3 out, we get 10x squared minus 9x plus 2. And we'll put that GCF on the outside. And now we're looking, I still can't do 1, 2, 3 factor tree because of the 10 in front of x squared. So I have to take it and slide it and multiply it to 2. So we have 3, and we have x squared by itself, which is what we needed, minus 9x, we don't touch that middle term, plus 10 times 2 is 20. Now we can do our 1, 2, 3 factor tree. We're looking for two numbers that multiply to positive 20, but subtract or add to negative 9. So that means I need two negatives to multiply to a positive and add to a negative. And that's going to be negative 4 and negative 5. So we'll write this as 3 times x minus 4 times x minus 5. But remember, we just borrowed that 10 when we slid it over. We have to pay it back, and we're going to pay it back by dividing each of these terms by that slider, okay, by 10. And their fractions, we're going to see, do they divide to a whole number or do they reduce? And they do reduce. 4 over 10 is going to reduce to 2/5. 5/10 reduces to 1/2. So they're both fractions, but we never leave fractions in our final answer when we are factoring. So we're going to do bottoms up. The number on bottom comes up in front of its x. And then we'll rewrite this. This will be 3. That GCF still sticks around on the outside. We have a 5x minus 2 and a 2x minus 1. So that was an example of our slip and slide or slide divide bottoms up. Now our last type that we just learned was factoring by grouping, and this is done again when we have 4 terms in the problem. So we just check. It looks like this is not arranged the way that it needs to be, or is it? Yes, it's just fine. So we're going to start by making a dividing line. We split this into 2 even groups, and then we take a GCF out of each group. So looking at 2a cubed minus a squared, our GCF will be a squared. So we're going to divide that out of each of these. 2a cubed taking away a squared is 2a. And then we have negative a squared b. We're taking away the a squared, so we're just left with that minus b. and then we'll put a squared on the outside. Looking at my second grouping, we have 10a minus 5b. The GCF of 10a and 5b will be 5. They don't have any letters in common, so just 5. 10a divided by 5 is going to be 2a. Negative 5b divided by 5 will be negative b. We wrap that up in parentheses and put our GCF on the outside. Remember, we have a check. If what is inside parentheses matches exactly, we have done this correctly. And it's only used one time in our answer. That was a minus b. And then our two GCFs, they decide to hook up and be in parentheses together. So a squared plus 5. And again, all of these can always be checked by multiplying them back out and seeing if you get back to the original problem. Factoring is taking a polynomial and turning it into a multiplication problem that made it. All right, you'll be ready for our activity now.